I want to keep this fun, interesting. I want to hear from you guys. I know you guys are tired. I know we just got done with lunch. For those of you that don't know me, my name is Nancy Hollenback. I am a certified LabVIEW architect. I work for NI, and so I'm a field architect, which means I work with my boss, Brian. Everyone should know Brian Powell by now if you do not know him. And so he runs our field architect program and our Center of Excellence program globally, and he's been a long time LabVIEW programmer. And so there's Brian and I and Charlie Knapp out in California. Is he a dad again yet?
Haven't heard.
All right, he's supposed to be a dad again, which is why he's not here at NI Week with us. And I highly recommend our blog, because not because of the last blog I put up, but if you're thinking about using the TSDN toolkit from Viewpoint, I did a quick review with a few highlights, but really it's this 6-series session that Brian put together on the eGoals program was absolutely fantastic, so I highly recommend that. So I'm going to warn you guys that at 2:59 or at 3 o'clock sharp, I'm going to grab my bag and run out of this room because I have a 3:30 flight. So I'm giving you my email address right here, so write that down. I have business cards that I will leave here, so I will not be fielding questions afterwards, but Brian knows everything there is to know about LabVIEW, so I'm sure he'll be able to answer any of your questions. Oh, and Christina's in the room, and then we have plenty of architects up here at the front that can answer your questions. So the session title changes depending on what I feel like, and right now it's still everything you ever wanted to know about functional and global variables. And so Norm Kirchner, who spoke on Alliance Day, stole my title when he presented on everything you ever wanted to know about user events. We have sometimes called this session Death to Functional Global Variables, or Learn DVRs, or something along those lines. But what I really think we want to do is let's look at functional and global variables, because they serve a great purpose in LabVIEW, and we want to understand when to use them, how to use them, when to throw them away, a couple design patterns that are based on functional global variables. So one of the reasons why it's important to learn functional global variables is that they've been around since the late 80s, somewhere around there, because they were the only way, and I have a slide we'll go into history, to store global data in LabVIEW, because there were, prior to LabVIEW version 3, it was LabVIEW version 3 when we had global variables, and so, so they are important. Let me ask you guys, who uses functional global variables regularly? Who adheres to the philosophy, death to functional global variables? Excellent. We fight this, we have this argument all the time internal to NI. So the key thing is know what it does well, know when to take that hammer and throw it away and go get a jackhammer or a screwdriver or something else. So that's just a little bit of a preview. And so we're going to talk about what it is. Who does not know what a functional global variable is? Okay, I've got one quick slide on that. If you don't know, you've got my email address. I'll point you to some information there. So I'm going to fly through those slides that are more introductory, since we kind of all know what they are. We're going to talk about race conditions, because functional global variables do not prevent race conditions. Action engines do prevent race conditions. And we'll talk a little bit about global variables. We'll look at DVRs as well, and then some cool stuff with DVRs in classes. So, why do we need them? They're one of our 40 different ways to communicate between concurrent processes. And so there's a variety of ways to communicate between concurrent processes. Functional global variables have been around a long time. But when we're thinking about this communication piece, the thing that we need to consider is, what is it I'm actually trying to do when I'm sharing information between two loops, or I'm communicating between two loops? And there's a variety of places in some of our courses where we kind of break it down to the different types of communication. And so the first thing on the list here is just global data storage. Really simple. I need to store information, and it just sits there, it doesn't do anything, but somebody can go pull some information out of my global data storage at some point in time. Sometimes with this asynchronous process communication piece, we want to stream data. And so if I'm streaming data, I'm probably going to use queues, maybe events, network streams if I'm going across the network or across application instances. And then there's sending messages, and the many different ways to send messages. And I have many things I have to think about when I want to send messages. So there's a lot of permutations and variations, and we're not going to touch any of that today. So I just want to emphasize that when I'm creating a functional global variable, I'm not creating a messaging system. It is just a simple data repository, and that's all that it is. And so what we want, there are times when I need this, when I have configuration information, when I have slowly changing information, kind of just some status information, and parts of my code may want to occasionally get that. They serve a very good purpose for that. So the data is actually made globally accessible, it's sitting there holding the current values, and then other modules just access it as needed. But we do have the potential for race conditions, so we want to look at that. So that is the purpose. So when I'm breaking down my application and thinking about what the different pieces do, this is the purpose of functional global variables in my application. So there's a couple benefits, and I'm going to highlight a couple things with regards to them as well. So first of all, we have the global access to data. Another key thing is we're encapsulating data. And so that means I'm protecting my data. That means there's data stored in the functional global variable that nobody else can access unless they go through my FGV. And that's important because that helps me with maintenance. A real key thing is reusable modules. As much as I can, whether it's a functional global variable or an API I'm building, I want to think more and more about what can I encapsulate. And if I have a functional global variable template, and we'll look at one in a minute, I can make sure that template is robust and it's debugged and it works, and then I have a design pattern that I can reuse over and over again, and I know it's going to work in my code. So we'll take a look at all of that. It does make things a little bit more reusable. So functional global variable review, an initialized shift register, that's where the data is actually stored. I'm not going to go into any details here because most of you guys have seen this, but the data gets stored in the uninitialized shift register, so I set it over here. The code can stop running, and then I can read it, and I'll read the value from the left-hand side. So why is there a loop here? I'm not running this over and over again because it's set to stop with true. Why is there a loop there? The shift register, that's the whole reason. So it confused me when I first learned this. You can do a for loop. You can do feedback nodes and get that extra fraction of a % performance, because there's better ways to get better performance than switching to the feedback. But this is the way most people do it, yes?
Quick question, are you making a distinction between functional global variable and action?
I'm going to in about 3 slides, maybe 10. Great. Right now we're just talking about the basics. This is common documentation, yes?
One extra buffer allocation instead of wiring the shift register out.
I don't know if I'm following the question.
You've got output wired to a kernel, which runs the data copy. Why not wire it to the shift register?
Yeah, it could be wired to the shift register. I pulled this slide from a course.
Oh, okay.
You know, and that's a good point. Yeah, very good point. But typically, you know, I might not always be trying to output the entire cluster per se. So a lot of times I'm just going to be grabbing maybe a value from within the cluster or something like that. But very good point.
Probably going to be copied.
Yeah. Thank you. Brian says it's probably going to be a copy account. That's why he's here, because he knows how many copies Latin makes one. Thank you. Okay, documentation. I think we have some examples somewhere online that showed something a little bit different, but this is the way we've been documenting these things for 15, 20 years. I've got input on the left-hand side, I have an output on the right-hand side, and then the method or the action or the enum is driving which case is going to actually execute is going to be in the middle. I want to put in parentheses what is the I want to have the default value. In this case, I'm not seeing the default value, but the default value of action I need to put in parentheses. I need to make sure that the get value is always the default. So in case someone doesn't wire the an enum actually to that terminal, it's not going to accidentally modify my data. So I want the default to be the get method, or I could set that terminal to required, meaning I'm forcing someone to actually put the enum up there. But this is what we're used to, and this is what we've seen on a regular basis. And I can figure out if it goes away, but now I think I know how to fix it. So we wired to the top connector, and so the history here, these things have a variety of names. Originally they were called LabVIEW 2 style globals, because in the first version of LabVIEW, that uninitialized shift register in LabVIEW version 1, and Brian will have to tell us who's responsible for that, and I never really defined what should that value be. You know, it's kind of undefined. Should it be the default value of the data type, or should it actually be a storage location such that when I write to the right-hand side of the shift register or the loop, that whatever was there is actually stored. So there's all kinds of urban legends of whoever came up with the way we did things in LabVIEW 2, but this is where the birth of the functional global variable was the LabVIEW 2 style global. It's been known as VI globals, USRs, components, you name it, and there's actually going to be a difference between an action engine and an FGV, and we'll get to that very shortly. So it was in LabVIEW version 3 that we actually introduced global variables. So everybody knows what a global variable is, and you go to our courses like Core 1, Core 2, Core 3, usually your instructor says globals are bad, do something else. And so then everyone takes something like this, and then they might just create a functional global variable, which is the set and get function. Does this solve my problem? No, this does not solve my problem at all. This is just a basic set get functional global variable. So let's take a quick look at the functional global variable itself. And so I'm not going to open up the global information there. With a simple set get, then the idea is, for those of you that are newer, I can have a VI open, and I have another VI open, two independent VIs. So this is my functional global variable. I'm not continuously running it. And so it's kind of important to see that when I increment this value over here, even when LabVIEW is idle, but my FGV is still in memory, then that value gets stored in my functional global variable. So I can make changes over here, continue to make changes, and grab it over here. So a functional global variable, the scope of it is LabVIEW, or an application instance of LabVIEW. So that those of you that are newer, LabVIEW has different application instances. 2 EXEs, different application instances. They don't share data space. And so these will not work if you have 2 EXEs. That holds true for queues and other things. And then, of course, these don't go across the network. Just as an FYI, anyone use CVT? CVT is a great design pattern that comes out of our system engineering group for RT. And so they have a nice mechanism for sharing data across the network, and very scalable. It's basically a functional global variable under the hood that has another piece of code that makes sure that those two are synced up. So if you're doing, so it's a pretty slick thing that's been around for a little bit, but it is based on FGVs. So let's take a quick look at the functional global variable itself. And all we're doing here is we're getting stuff, and then we're incrementing, and then we're setting it. This is bad. But if I just want to make sure that I highlight and open up the functional global variable, what I'm basically doing is I have the uninitialized shift register, and I only have a set and get. So this is only just storing this particular value. And so what we're going to take a look at is the fact that this does not solve a race condition, and we really need to change this a little bit, turn it into an action engine to actually solve our race condition. All right, so the question that I asked earlier, which was, do FGVs eliminate race conditions? And the answer is no. Because if I look, this is kind of how our example is structured. If I have a VI up top and I have a VI at the bottom, and what can happen is, LabVIEW is going to try to set this up so it's executing both of these in parallel. Run a little bit of VI1, a little bit of VI2, back and forth again. So what LabVIEW may choose to do is LabVIEW may execute up here, and I get a value, and before I'm able to modify it and set it, then this VI starts running, I get the same value, and so I'm actually overriding this because these values are both the same. What I want is to have this complete execution, and then LabVIEW will run this, so both modifies take effect. So that is the issue that we want to make sure that we take care of. So let's look at the race conditions with that. All right, so I've got a VI. Let me do this first. It's a little bigger. All right, so I'm going to run this and stop it, and we're going to open the code. But the idea is I've got 2 loops running, and the total iterations is going to be some value, but because I have a race condition here, I'm not going to catch everything, and we're going to have this overriding going on. So we'll take a look at the block diagram here. So we've got the 2 indicators, total iterations, and then the current value that's being stored in the functional global variable. So what I have over here is I'm really just incrementing. Each time I go through the loop here, I'm just doing an increment. Each time I go through the loop here, I'm just doing an increment. And so I should be able to add whatever is finally stored here at the end to whatever is finally stored here at the end and get the current value or the total iterations. But I'm not getting it. And then if I run this in execution highlighting, that's where we really kind of see what's going on, because what we'll have is the top one will get a value, and then it's 0, and then the bottom one gets 0 as well. They each get incremented, and then they each get set back into the functional global variable. But what you really want to have happen is get a 0 in the top loop, increment it, finish, then the second loop will read a 1, increment, and set a 2. So this is the issue that we want to solve here. So what we're not doing, and the issue here is we're not protecting this critical section of code. And so that's what we want to take a look at next. Any questions on that? All right. So, come back over. Sorry about this. I'm always back there. So we have a race condition with just a plain set get functional global variable. But what we really want to do is we want to use the functional global variable concept to protect critical sections of code. Because when I'm doing that, then I have the ability to prevent these race conditions. And this is what we call an action engine. So that was the question that was asked, is, you know, we're going to distinguish between an action engine. So an action engine is a special kind of functional global variable. So we want to identify the critical section of code, figure out how we're going to want to modify it, and we want the entire get, modify, and set packaged in the functional global variable itself. So when I look at an action engine, instead of having it just set and get values and the FGV, I am actually going to do the actions. And so what you saw in the previous code was the functional global variable got the value, then we had a case structure that modified it, and then it set it. We want to put all of that into one VI. So what I'm doing then is I'm getting the value from the shift register, then I'm modifying. This is my critical section of code, and then I'm setting it. So I want to make sure that I'm wrapping the entire get, modify, and set around that critical section of code. So we're gonna digress for a second, because one of the things that we need to understand about LabVIEW is how this works in LabVIEW and how LabVIEW works by default. And so we're going to have a little sidebar conversation here to explain kind of what's going on under the hood. And one of the things that we need to understand at some point in time in LabVIEW is this thing called reentrant execution and non-reentrant execution. And if anyone here is a little bit newer, I remember the first time I was taking some of our early courses and reentrant, what exactly does that mean? Well, we're going to talk about that a little bit because it does affect, and it's part of why functional global variables work the way they do. So the concept is the LabVIEW execution system will not run multiple calls to the same VI simultaneously by default. When something is non-reentrant, this is the default VI properties, reentrant execution is not checked. That means it's not reentrant. That means LabVIEW, if I have 2 calls in memory, are going to share data space, and LabVIEW will not run them simultaneously. Sometimes I think our terminology that we come up for things throws me a little bit. So, but let's take a look at it like this. I want my functional global variables to be non-reentrant. Okay, so what happens if something's actually reentrant? Let's look at the left-hand side over here. If I have a VI that's set to be reentrant, that means I can run those 2 instances at the same time. So when I'm thinking about Darren Nattinger's queued message handler and the VIs there that are driving all that, I'm going to have multiples of these things running at the same time, so I want the VIs to run at the same time. And when they run at the same time, they're going to have their own data space. So each instance of a VI will have its own data space, meaning it's not sharing anything that gets stored in an uninitialized shift register. And so each instance has its own data space, and there are times when I definitely need things to be reentrant. So the other piece is when it's not reentrant, and these two VIs are run independently, they share the same data space. And so that means things like uninitialized shift register is maintained between all instances of the functional global variable. That's why I had two VIs running in that first example. One VI I'm incrementing, the other VI I'm reading the value, because I have the FGV function call in both of the VIs set to non-reentrant, and so they're sharing that data space, or that uninitialized shift register. And so, so functional global variables will be non-reentrant. Now, for the advanced users out there who know Nate Mooring, who's one of our CLAs and running our CLA summit, there are exceptions to the rule. You can do things that are reentrant with non-shared clones, but we're not going to go have that conversation. But I do leave a bullet in here that there is an exception, and you can go ask myself later, or you can ask Nate. So that is why then, when these two VIs are both in the block diagram, they will not be running simultaneously. So I know that one VI is going to complete execution before the next VI completes execution, so I can guarantee that the get modified set completes in one before the other happens. So that is why this all works. And so the shift that I want to make then is, instead of having this get modify set and there's three different entities, I want to protect it in one VI, because it's the combination of the uninitialized shift register and the non-reentrancy way that LabVIEW runs that allows me to do this. So if we take a look at the next demo, it's already up here. So when I'm running this one and stopping it, the values are identical, like they should be. So let's go look at the code. So it's the same code that we saw. If I open up the functional global variable, I can see that I have, here's where I'm getting the value, here's where I'm modifying it, here's where I'm setting it. I'm also putting in the 100-second delay that you saw in the other code, just so you can see that this VI, even if I have 100 millisecond delay, is going to complete execution before the next instance runs. And so when we run, we've got total iterations over here, and we have our actual value and our functional global variable. So what this is doing then is I know that I'm getting, incrementing, and setting. Then I get increment set. Then I get increment set. These are both atomic operations that complete before the next loop executes. So that is an action engine. Questions on action engines? Yes?
When you say use DVRs instead, does that also apply to action engines? Instead of like regular old functional global?
Well, it depends on what you're actually doing with your functional global variable. Because if you're doing something like this, where you want to make sure that you don't have that race condition, then it needs to be an action engine, definitely. Or you could do a DVR as well. Now we're going to have another illustration of using a functional global variable as a key value lookup table. Well, if I have a key value lookup table and I'm doing things slowly, there's times when that could work really well. It's not an action engine. It's just another design pattern built on functional global variable. Yes?
Do you use an action engine also as an FGV?
An action engine is a special type of FGV.
Yeah.
Yes. Does that answer your question?
Yes.
Great. Yes, an action engine is a special type of FGV. Absolutely.
You might do like a get and an increment, but probably you might not do so. Basically read what is the current value and actually modify it.
Right. In the interest of time, when I give these slides out, I will take my hidden slide and make that available. And you have my email address, send me an email. Because it's about a 5-minute answer to that, but it will be in the slides, I just want to show it right now. Oh, yes, and back to the blog page that we have, Brian has a blog post on this as well. All right, speed. Global variables are a lot faster than functional global variables. I mean, I can run into an instance where an FGV is not fast enough. In fact, a little bit of history on our API for our configuration file VIs, the ones that allow you to create the INI file. Under the hood, many years ago, it was really a functional global variable, but we had speed issues, and so that was rewritten. Everything under the hood was rewritten probably 3 or 4 years ago, maybe 5 years ago. Global variables are a lot faster, but with a functional global variable, which is not a feature in LabVIEW, it's a design pattern, we get this extra code to kind of check for valid data, and it allows me to create something that's more robust and a lot more modular. Now, one idea that got tossed around a ways ago, and I don't know if anyone's ever picked it up, but I really liked it, because Mercer put it on LavaG one time. He's like, well, what if we use a project library to protect a global variable? And so that's where I'm going to get speed. So if I want the functionality of a functional global variable, but it's not fast enough, this is where you can solve your problem. So what you would do is create a project library, make your global variable private, and then have access or VIs. And then when you encapsulate all this, you set it up so it looks just like a functional global variable. So someone who's used to seeing FGVs will see this. They don't know what's going on under the hood, but it's a lot faster. And so the thing is that we need to know about, so for those of you that aren't familiar, I can change the access scope of items in the project. And for those of you in the back of the room, there's a teeny tiny red key on the VI, which is the actual global VI. We all know the global variables are actually a special kind of VI. So since that's private, if anyone else tries to use that global VI, because this is my problem with globals, is I put them all over the place and I have no way of protecting who has access to it, no one can use my global variable, period, because it's now private. And anytime someone tries to use it in LabVIEW, I'm going to get the broken arrow. And so then what I do as a developer is I started off with my encapsulated global project library. I have my global at the bottom, and it's the red key. And then I have some functions that I'm going to start adding to it. So at the end of the day, this is what it looks like for my end user. My end user grabs count.vi, which is the function. It's the public wrapper around the global variable, and so this is what the user sees. It looks exactly like what we had with our functional global variable. The difference is that underneath the hood, instead of storing it in an uninitialized shift register and writing it back to an uninitialized shift register, we're just using the global here. So the only way anyone can ever do anything to this global variable is go through my API, go through my public interface that I've given for them. Yes? Sorry, over here. Globals are just faster, by a factor of 10. In the code, I have some benchmark, and when I was playing around with it, if I do the same thing, and it depends on what you're actually trying to do, but when I benchmarked it, it was 10x faster. But globals have already been faster, the functional globals.
Is that VI that you're pointing to the thing with GDL count.vi?
GDL count is the global, because globals in LabVIEW are a VI. They're a special kind of VI that doesn't have a block diagram. So this is GDL count.vi.
Where is the thing that's above it?
This is count.vi, the thing that's highlighted in blue. And then this is what's going on behind the scenes here. Yeah. So I can open up, thank you for asking that. I'll just open it up. I'm not going to run anything, but I'll open it up real quickly so you guys can see. Pardon me? Well, it's still, I think it's still slow. That's a good question. You'd have to really benchmark that. And I'm sure there's different use cases that don't have quite the 10x separation. So here is my encapsulated global. This is actually, so this is what we see here. So this is the encapsulated global. This is actually the global variable itself, which is a special kind of VI that does not have a block diagram. And then when we use it, this is what it looks like when we use it. Looks like an FTV, we just changed everything under the hood. So it's also good to know we might consider locking and password protecting the LVLIB. When we actually lock it, then people don't see what's private inside a protected library. So that could be pretty cool as well. All right, so we're going to shift because we're going to look at another design pattern based on a functional global variable. And so this design pattern allows us to create a nice reusable component that's good for a key value lookup table. And so I can do a key value lookup table. And this is the kind of thing where I configure something in the beginning of my program, and I only really set things maybe at the beginning or one kind of tightly controlled area. And then later in my program, I just want to be able to access something that has a named reference for it. Not reference in the sense of a LabVIEW reference, but it's a named value lookup table. So the example here is a named value lookup table for storing passwords. Maybe device aliases, anything that I have a group of things that I want to access them via a name. So when I look at my name value lookup table, and this is what's going to go on behind the scenes, but I'm going to have a functional global variable, and then when I enter the name and select a certain method, then it will either say, yes, this is, Mary has something in the lookup table, and here's her information, or you tried to get data for Bob, but it's not a valid data set. So this particular template has all the error handling going on behind the scenes to make sure I don't have duplicate names and to make sure that when I retrieve a name, it has actually been set at some point in time. When I first start running, there's no names on the table. So these are the methods that I'm going to have for my lookup table. I can add a data set, modify it in case Mary wants to change her password, get, delete, get all data sets, delete all data sets. This is set up as a .vit, and it's set up as a .vit, and we're going to see how we can start with a .vit. We don't change the code at all. We just define what is the type of data that we're going to associate with the name lookup, and I don't change code. I just change a type def, and I'm ready to go. That's it. And so these are the kinds of components that we want to think about building, and this is one that's built on FGVs. So if I look under the hood and see what's going on, I have two uninitialized shift registers. So they're each going to be an array of 1 item or 3 items or 10 items. The top one up there is going to be the array of names. The bottom is going to be the array of the actual data sets themselves. So that I can see that when I did the get data set, and if Bob's name was not found in the list, then I got an error, and the error returned false, saying this was not a valid data set. So this is already built into the .vit. It works, so it makes it really easy for us to build components from it. So I'm going to come back to LabVIEW, and we'll just first run. So I want to change this to an add. And this actually, in this example, I'm running over and over again, and I actually call the functional global variable. The only time I call a functional global variable is when I specify do action. So I just wanted to show that. Functional global variable is sitting right there. So if I want to add a data set, give it a name, my daughter's password is popcorn to her laptop. Did you see my daughter's laptop in Colorado? That's how you can get on it. What's that? Yes. Oh, you? And then I'm in trouble now because we'll be happy. My son has some variation of the word Ferrari, so we're going to add that to the list. And then if we go back and try to get what was the name for Evie's, because she does forget her password from time to time, it was popcorn. And then, of course, we find out, okay, what was Mom's password? Well, I have not been entered into the ongoing list in memory, so it says this is not a valid data set. So that is using a functional global variable as a lookup table. And so that's using it as the lookup table. And then we want to be able to take a look at the .vit, and we want to think about when would we actually use this. Well, it is nice because it can become a nice built-in, drop-in reusable component. We have the protection So we know we have valid data. Things like storing references is something that we could easily do, because do we have something in LabVIEW that has, did we get named references for user events in 2013? DVRs aren't named either. No? So there's several things that we might have references we want to store, and we have to have a name value lookup table. Operator interface, just anything that has this paradigm. So if we want to create our own, all I have to do is go to the template, and just a note, because this is a subtle thing, if I double click on FGV resource template .vit, am I going to create a new VI from the template, or am I actually opening the template itself? Who thinks I'm creating a new VI? Who thinks I'm opening the template? There's a lot of I'm not sure's too. What I need to do if I want to create a new one, if I actually double click on this, I'm opening the template. So it's good to remember that. Whereas right now, I'm going to just right click and create a new VI from the template. So we've got the template, and there's only one thing I really need to change. And for instance, we saw name value for string. Well, what if I want to have a name value for numeric or something else? So this right here, I would simply open the type def here, and then I change the data type. So I'm going to replace this, and I will make it a numeric, and then I'm going to save this with the rest of the clutter on my desktop. And then we're going to apply it. And so that's all I have to do, period. That is all I have to do. So then when I've got this open over here, it's going to act the same. So I can say task 1, set its value, and I want to add the data set, okay? And so I'm going to add task 1, and then if I want to add task 2, set it, get the value from task 1, and it's 44, and so we see it is indeed 44, and it is a valid data set. And then if I want task 7, of course when I read it, it says it's an invalid data set, which just has the last value. So it's really simple to be able to take that and extend it.
Would that be faster using 2 globals instead? Would it be 5 times faster?
I'd have to benchmark it. That's a good question. Now, you bring up a good point though, and I think I left it out of the slides. No, actually, it's probably, I think I left it out of the slides, but it's up here. When we're thinking about what's going on with the lookup table here, if we actually look at what's going on behind the scenes, and we'll open up the actual template itself, then this is just a basic search VI, and it's not that fast. So if I want to make my functional global variable faster, but keep it a functional global variable and not go to globals, then one of the things I could, well, and especially I have to do this with the lookup table. If I want to do this lookup table paradigm, then I can use a variant attribute instead. Because for those of you that are unaware, there is, on variants, there's this thing called set variant attribute and get variant attribute. And so the hash lookup table for this is significantly faster. Now, if we really want to get complicated, it is faster to do the lookup here. Actually, removing the value from the variant can be slower than a functional global variable. So those who are like really excited about being as high performance as possible, and let's say your lookup table has thousands of names or 1,000 names, you want like 20,000, you want to use this for your lookup, and it gives you an index into an array of the actual items. So we can talk about that more offline, but I wanted to highlight this in a couple of the nuances. All right.
Faster than a binary search?
What's that?
Yeah, it's faster than a binary search?
It implements a binary search.
Oh,
Yeah.
okay.
Darren Nattinger can speak to that. So go under Darren's nuggets on the NI discussion forums, and he went into a little bit of details on that. The other thing that's nice to know about variant attributes is you don't have to just store the same data type, you can store any data type. into a variant attribute. And so you can set, it can be a great storage for a lot of things, pretty flexible. So just wanted to highlight that, and we'll take a look at it. All right, moving along. So what if you need multiple counters? And I actually did this one time, and I felt so stupid. We all have those moments in LabVIEW where we do something, it's like, really, I just did that? Because I was trying, I was using a timer that was a functional global variable, and I was trying to time two things at the same time. I was like, why is this not working? It's like, I'm using a functional global variable, and there's one of them that's overriding the other one. So one of my functional global variables was kind of like timing out every 5 seconds. The other one was 1 second, and they were overriding. So we can only use this one time. So this is a singleton design pattern. So a lot of different ways we can have multiple counters. So we're not going to have that discussion right now. There's a couple of options right here. We're going to go down the sidebar. And one of the things that we're going to mention quickly in the sidebar is when you're programming in LabVIEW, you want to be cognizant of what is on the wire. Does the wire have data? Is it a cluster or a class or an array? Or is the wire actually a reference? So a reference wire in LabVIEW is like a pointer. So we've all seen producer, consumer, design pattern, feed, message handler, everything else. When the wire forks here, I effectively have a reference so that I can do something up here and see it down here, because they're basically pointing to the same data space. And so in this case, this is a Q reference. So forking the wire creates just a copy of the reference. Now, what I might want to do is with my data storage, now we'll think about queues, since I got queues up here, so I want to do it in a quick analogy, is when I'm dealing with queues, I'm actually sending messages. When I do something up top, I send a message, and an action, something else occurs down here. This VI runs and pulls the data off. So queues are a good messaging paradigm. What if I want that dumb data repository? I don't want to send messages. I just want to store data. Then I want to use this thing called a data value reference. So who's already using data value references? Cool, excellent. A couple hands have gone up. I'm going to digress on something with data value references shortly for those of you that are here that have used them before. So the idea is I want to wrap a reference around my data. And if I wrap a reference around my data, I'm going to show you guys what we ideally want to get to. We want to get to the point where I can have multiple loops running in parallel. So I'm going to run this, and this is in one loop. This is in one loop, and this is in another loop. So I'm going to set the value in the producer loop. Oh, I was playing games with this earlier, right before the session. Hold on a second. Darn it. Hold on. Yes, exactly, exactly. This is, yeah, hold on, here we go. Let's go to, yeah, close it. Okay, that's odd because, okay, I'm going to do something really bizarre here because this is not broken right here.
But the reference going in is valid already.
Yeah.
Like that.
Okay. Yeah, because I did not type this. But when did I change? When did I changing? Oh well. Okay. When I don't have issues, we can still look at the block diagram and see what's supposed to happen. So we're going to look at another one.
You create 6 references on the block.
Yeah.
And you just try to increment them.
Oh, that's what I do every single time. Thank you. It's like, wait a minute. I made this same mistake when I gave this presentation last year, and Aaron kindly corrected me. All right, let's run. Okay, there we go. Kurt, thank you for saving me. Aaron saved me last year. That's just not going quite so high. All right, simple answer. It's always the simple thing, and I always look for the complex problem. Yeah, I could do, yeah. All right, smarty pants. Well, you know, the problem is, I wrote all of this, and I didn't go through the appropriate code review process with Craig, who was going to find this for me in our code review process. I don't know if anybody made it to Brian Powell's code review process, but I did not have anyone buddy my code, and clearly I did not bowl my code, which means put it in the source code control. So I've got buddy issues and bowling issues. So basically what happens then is I'm able to, in the top loop, I'm able to increment or set the value or increment it up there. It's being stored in the functional global variable, and then in the bottom loop, I'm just getting all my current values in the bottom loop. So in the bottom loop, I'm constantly getting my current values. And so I have this reference, but both of those, it's all pointing to the same data spot in memory, or the same memory location. So now I have 6 counters. And so this is a clean and elegant solution when I need multiple instances of something that is actually storing data.
Excuse me. Since we're probably making the same mistake, what was the error?
Oh, what was the error? It's like one of those really embarrassing errors that if you've been doing stuff in Labby for 20 years, you don't want to do it. But I have this array over here, and I'm creating references for 6 items. And so when I try to reference, as soon as I'm here at 5, I'm going to increment the last one. Oh, I'm not running. It would help if I would run, right? So increment the last one, but then as soon as I hit counter number 6 and increment, I'm getting an error. And if I go look at the actual code, and I'm going to stop, if I push to say stop, what I'm doing here is I have a lookup table, so that the counter number is just an index into the array of those 6 counters. And as soon as the index is trying to find index into an array of 6 items, and if I'm trying to get an item that's not defined in my array of 6, it's going to get the default value of the data type, which is an invalid reference. So it all makes perfect sense. So I'm glad you asked that question. I should do this intentionally every time I give the presentation.
You really did this time, didn't you?
I really did this time. All right, so that was our talking about references, and so when we're looking at how do we create this, what we have is it's buried in the application control palette, and then you go into memory control. We have these 2 VIs, which are called new data value reference and destroy data value reference. And then we have this in-place element structure, which I'm not going to go into a lot of detail right now, but this is a structure that allows us to bring in an array in, operate it on memory, not make a data copy, pull the array out. So this is when we have an in-place element structure, it sits in the block diagram, we right-click, and then we can add a DVR reference onto this. So this is how we're going to access the information, or in other words, unwrap the reference wrapper around our DVR, do something with it, and then put the reference back around it. And so this is what we're going to end up with. When at the end of the day, what I want to do is have my library, and I've got an obtain and several other items here. It's called dvrcounter.lblib. I'm going to put everything in a packed library. I'm leaving my template in there, so I have a template that I can start with. So if I need to add another method, I can easily do that. I have my obtain or my create or my constructor, and then I have my release or my destroy or my destructor. So my preference, this is where I'm going to ask a few of you guys that have done DVRs, I like wrapping things into a nice library, because it's really nice as an architect to be able to give someone a library. They don't care what's going on under the hood. They don't have to know about DVRs. They don't have to see the in-place element structure. They just need a nice clean API that's easy to use. Now, we had an argument at the CLA Summit in Paris this year, and so I'm plugging CLA Summits who want to get your CLA and come to the summit in Austin or Paris. And we had an argument about, should we do it this way? Or should we expose the DVR or the in-place element structure in the block diagram? And we were talking about classes and DVRs and wrapping classes and DVRs and how do you do it, because there's 5 different ways to do it. Does anybody want to pipe up on their DVR usage and add a tidbit? Yes?
Wrap it in the library.
What's that? Pardon me?
Wrap it in the library. It's a much
Yes,
safer,
wrap it.
saner way to work.
Yeah, wrap it in the
Otherwise
library.
you get that
But what was
split
interesting is
reference.
we were arguing, and we want to wrap it in the library, absolutely. The group was arguing about the best way to do all this, and we were coming up with these very elegant, complex solutions with how do you wrap a class hierarchy, and where do you put the DVR, and Jeff Kodosky said, well, you know, I just kind of like, I'll have my class hierarchy, and if I need a reference around it all, I'll just put a reference around the entire class, or the parent class, and then unreference it at the end. It's just a nice, clean solution and idea. It was great to have him pipe in on, we're coming up with complex ideas, and he came up with a nice, clean, elegant idea. All right, so we're migrating now, because some of us in the room are going to trash all of our functional and global variables and move to DVRs. And you're thinking, how long is this really going to take me to do this? So the first thing you need to know is if it is a cluster, make sure it's type def, because you're going to add things down the road and you don't want to have the, you don't want to mess up your DVR references. But really the transition is very simple. So on the left, we have the functional global variable. So what we're effectively doing is we're going to take the code that is inside each case structure, and it's going to go inside an in-place element structure, and it's going to become a single method in the overall library. So in my counter, if I have increment, decrement, get value, so if I have 3 case structures in my functional global variable, then I'm going to end up with 5 methods in my DVR library, because I'm going to have my constructor and destructor that create and release the reference, and so then each actual case here then becomes its own method right here. So we start here, copy code, put it in the in-place element structure, and then we also have to create our constructor and our destructor. So if we look at the overall library at the end, it might look something like this. So the code for the obtain is up top, the code for the increment is down at the bottom. So it's really a pretty straightforward, easy way to do this. Now I don't know if anyone has created a tool to automatically do this. Has anyone created their own tool to easily automate some of this? Maybe someone could create a tool, put it on the tools network, and then pay for a vacation that way. So the idea, and the nice thing, is there's some value here in several areas. One of them is I am controlling when LabVIEW is creating a copy of this data set in memory. Because when we have a forked wire, LabVIEW sometimes makes a copy. Hence our earlier conversation. If I have a very explicit constructor that is going to create a reference around a data set, that's when I'm creating that, or allocating memory, and then the destructor cleans it up. So when I'm dealing with very large data sets, this could be a value add for controlling when I'm making copies of data. The other thing is think about a functional global variable. A functional global variable has one PI, one connector pane. And so if you want to be able to grab different pieces of data and get creative, you have to put another API perhaps on top of that functional global variable. So if you're going to start doing that, you might as well move to the DVR, because then what's actually stored here is never going to be just a count value. It might be a cluster with a lot of information, and sometimes I'm removing a string, and sometimes I'm removing just a numeric.
Is that faster than a global?
It is faster. I can't tell you how fast. Mr. Benchmark, Mr. Dr. Damien Gray, have you benchmarked anything recently?
Sadly, DVRs are actually a little slower.
Globals,
Yes.
but not functional globals.
Functional globals, the last time I benchmarked them for scalar values where they're almost useless, they are on par with DVRs. For almost anything else, clusters, arrays, they're going to be slower.
Okay.
Primarily because you're thinking about
Right, exactly.
Actually, we're just slow. The
Functional global variables is the slowest. So for those of you in the back of the room, we were asking about benchmarking. Dr. Damien Gray has done a lot of this before in the past, and so if it's just a scalar value, a functional global variable might be as fast, close to a global or a DVR. So if we look at the order of speed, globals are always the fastest, DVRs are a little slower than globals, which I'm really not surprised. And then the functional global variables are the slowest. The difference between speed gets worse when you have the larger data sets that make the copies. Yes, Dave?
I use this for visa references. That's I'm using functional globals.
One of, in the interest of time, because I'm really going to run out of here in about 5 minutes to catch a plane, you've got my email address, and that way I can make sure I understand your question really well so I can answer it well. All right, a couple quick things, and then I'm going to point out some fun stuff with related to DVRs. We want to add the methods as needed. We want to make things look like normal APIs in LabVIEW. We want our users to have a nice experience when we put together a library with them, for them. It's good with DVRs to make sure that you have an owner of the library who's going to update it and maintain it. So I might update it and maintain it for myself, but if I have a development team, I'm going to have an architect building this, and then I might have CLADs or certified LabVIEW developers actually using it. The thing is, people say, well, DVRs are complicated. DVRs aren't complicated. They might be complicated to build my library and to think about it carefully, but anyone who does basic LabVIEW, anyone who can do open file, write file, read file, can use my DVR-based library. So that's an important thing to bring up. So we know what we're talking about when we're talking about complicated things. All right, we're going to shift gears, and we're going to talk about classes. Actually, I'm not going to talk too much about classes, but I'm going to point out something really cool related to DVRs and classes. And I will leave it to you guys to do further investigation. But this is a fun thing. I was really pleased when I learned about it many years ago. And it can be very, very useful. So what we want to do is, and this is an important question to ask in general, is when I'm thinking about things like queues, like any kind of data, any kind of messaging mechanism that supposedly takes any data type, I always want to ask the question, well, can I use it with classes? So for instance, queues can pass classes. So a class can be the data type of the element. Notifiers can. Network streams cannot. So it's an important question to ask. So my question is, well, can I wrap a DVR around the class? Well, yes, I can wrap a DVR around the class. So if I have this little class here that's called device, and if I take a look at the create device, and I look under the hood, it is simply, I take my object wire it, and now I have a reference around my class. So for those of you that do things with classes, then what I have over here is this is the code that we're going to run, and I'm going to create a bunch of devices. So I'm going to have DVRs around each one, so it's an array of DVRs around classes. Now, one of the things about classes that's really cool is that I have this ability when I have my accessors, I don't have to use VIs to access data in a class. I can do it through a property node. So if you don't know about that feature, I can wire a class into a property node, and anything that has an accessor over here, I can then just go to my pull-down menu and select the appropriate thing that I want to either set or get. It is so cool because when you have classes that might have 50 items in there and you need to be able to access, sometimes I want to access item number 5, and sometimes I want to access item number 6. This is really powerful. Now, the nice thing is, when the class is wrapped in the DVR, I can still access it through the property node. And if I want to do any code behind the scenes, like limit checking or something like that, I can put that special kind of limit checking over here if I absolutely need to, and that gets executed. So in that node there, I am unwrapping the DVR, then figuring out the appropriate accessor that I want to run that code, rewrap the DVR. So there's a lot of stuff going on under the hood. So And that is, that's something that's really nice about DVRs with classes. So I think I've got approximately, I think I'm over by 1 minute, but I'm going to show one last thing, and then I'm going to run fast to catch a flight back to the place that does not have triple-digit temperature in the middle of the day. I'm going to show this. I'm not going to explain it, but you've got experts at the front of the room. There is help on it. So this is a feature of classes in LabVIEW. So what I'm going to do is I am going to, I'm just going to set these values to 0. And yes, I should initialize them to 0. So I am going to run this, and I'm going to set a few different devices here. So we'll set another device. And then I'm going to save this, and we'll call it NI Week Rocks. And then I'm going to stop. And I'm going to go on and just put these back to 0, so you see me doing that, so I'm not doing any magic. Now let's say somebody edited my class. This is the magic part. Somebody's going to edit the device class. So if I go through here and edit the device class, and I decide I don't want this value in here, maybe I decide just to add a value. So I'm going to add a value into my class private data. I'm effectively changing my cluster. And so I can, I'll go on and save it, and I will apply changes. Apply changes and save. Great. Come back over here to my code, front panel. I'm going to read the previously saved file. So effectively, what goes on behind the scenes with classes is I'm going to then, there's a file that's been saved. It's one kind of cluster. I've mutated it, but I can still read the whole file. Pretty slick. I cannot do that with clusters. It's painful with clusters. So I'm going to run it real quick. These things are all set to 0, and I run it, and I go tell it the file I'm going to read, and I'll say OK. There's those values. That's worth the price of entry. So we started with functional global variables. We looked at 2 design patterns, which were our action engines and our lookup table. We figured out how to make it faster. We went to DVRs, and then we did a totally wacky direction with DVRs and classes, and we ended up with classes. But this is a cool feature. You can look it up in LabVIEW. Thank you all. Everybody have safe travel. Questions, go to my email address because I've got a 3:30 flight out of here.